So I'm gonna give a core data fundamentals talk. Uh, I don't know how many of you guys believe they're awesome at core data. Can you raise hands? One guy. That's okay. That's good. Two guys. Nice. Yeah, core data is a pretty heavy framework. There's a lot of things you can do around core data. You can go from like really newbie stuff to like multi-threading core data. So who the fuck is doing this talk? Well, my name is Phillipe Casorla. I'm definitely not from Sweden. I've been in Sweden like 8 months. I work for Lifezone. I'm not going to talk about the company. We're pretty much in the corner between health and technology. We build apps for iOS, Android, and web. And yeah, I've been working for Lifezone for a while. I've been working on startups also for a couple of years. I met, probably some of you guys know Nicholas from the CTO of Lifezone. I met him in New York, and one thing led to another. I'm suddenly living in Sweden. So a bit of what I'm actually doing right now. Well, when I was hired, I was the current app. We actually went from being Shape Up Club to being Lifezone. And the first thing I said to Nicholas, my boss, like, yeah, I'm not working on that app. It was completely messy, really old technologies. It was using raw queries directly through an SQLite database. And we pretty much decided to start the app from scratch. That was like 6 months ago or more probably. And this is the current version. We're pretty much completely different. We're now using core data for everything. And it's been awesome. We were on one of the best apps in different countries in Europe last year. Pretty good. And then a bit of... oh, it's not recording?
Yeah, sorry.
Okay. Okay, no worries. So just some of the things we're going to see today. A really fast intro on core data because core data is huge. First, I talked with Martin about doing multi-threading with core data, more like a bit more tough. But we're going to go for fundamentals now. So a bit of fundamental classes. Let's watch some code, queries, migration, mistakes, and some random tips. Yeah. So really, what is core data? I mean, I copied this from the Apple Docs because it's really weird stuff. Provides generalized and automate solutions to common tasks with object lifecycle, object graph management, including persistence. So it does a lot of stuff. It does a lot of stuff for you. It handles change management, saving and retrieving objects from different stores, which you can choose in memory, SQLite, files like XML, or you can just go binary. It's not a relational database per se, because a lot of people confuse that, like you're using another MySQL for mobile or something. Keep that in mind at all times. And the cool thing is that it abstracts away a lot of the messy things. It's less code than just hacking your own SQL queries. But it gets really complicated if you want to scale it. We're going to see a bit on that. And well, as I say, you don't have to write any SQL. If you decide to use SQLite as a storage, you can create pretty complex queries with NS predicate. And if you're not using SQL, you can actually do functions for queries. So if you're using like a in-memory database or a file, that's pretty, if you don't know anything about SQL, it's pretty handy. And it does database migration, which is pretty cool when it works. When it doesn't work, you don't have any idea what's going on. But yeah, as I say, core data does a lot of things. And that's why you really need to know if you want to use core data, because everyone, the first thing that when they're building an app is like, we really need to use core data. It's like super trendy. And it's like, yeah, I just use all libraries. But it actually, depending on your app, it adds a lot of complexity that really is not necessary, especially if you don't want persistence or you're handling a lot of data. So why you really shouldn't use core data? I think this was pretty interesting. So the reality is that it adds a lot of complexity, especially when scaling. You probably will need to do some multi-threading of core data, and that's like the worst thing you want to see on an app. To really leverage the power of core data, you need to know a fair amount of Cocoa technologies, concepts, and patterns. I think we're gonna see it. We can start really fast with core data. You can just enable core data on a new project, and it will include all of the basic stuff. But it's definitely not ready for shipping. And as I say, you can definitely use like GitHub repos like FMDB for SQLite native, and for most of the cases you will get pretty much done. Yeah, as soon as you start working with multi-threaded core data, things start to get really tricky, and especially if you're handling a lot of data, you're not going to block the main thread, and you really need to do stuff on different threads at the same time if you're calculating metrics or things like that. So it gets quite a bit tricky. I mean, you need to read a lot, I'll say. And one of the things that is really bad on core data, and you can do it like in one query in SQLite, is doing a lot of actions through a large number of objects. Because in core data, once you access one object, it needs to load it on memory. Even if you're doing that for 2,000 objects, it needs to load them all in memory, even if you're changing the same property on all of them. You can do that in one SQL query, which it also comes with, you really never shouldn't use core data and access the SQL file at the same time. Just like fuck it, let's do a query manually. Never do that. Core data handles a lot of things on the memory. It has persistence, and you completely fuck it. And yeah, and importing large amounts of data. I mean, there's a couple of solutions here. Some people decide just to have a database included on the bundle. Some people decide to just load it on the first time on a different thread or things like that. But it definitely gets a bit tricky. And some of the fundamental classes on core data, just like the really basic stuff, you first need to decide a storage. It's going to be SQL, XML, binary, memory. But memory is pretty handy if you're doing unit testing. You can use that for speeding a lot of the stuff. And on top of that, you're going to have the persistent store coordinator, which is the one who is going to know how to read and write depending on the storage and how he's handling all of that data. And on top of that, you have the managed object context, which is the one doing all of the object graph, the persistence, the lifetime of each object. It really handles all of that seamlessly. And for that, you need to define an configuration file that includes all of your entities, the relationship between entities, the property types. And for each entity, they're going to be an NS managed object. So I think this is like the most simplified standard way of using core data. Like, you could do so much stuff, but this is really just simplified. So it's really, let's watch some code. I think it's the best way of just learning how core data actually works. Cool. Let me change this. I guess I'll mirror on this one. Cool. So the first thing you can do, you can just go to Xcode, create a new project. Let's use master detail application. I don't know. Example, Cocoa. And just select you want to use core data. It's just as simple as that. It will handle all of the stuff you really need to do. And some of the, I mean, you can start dealing with that. So the first thing that you'll see, I don't know, is that is that the resolution enough? Can you guys read? Fairly? No? Okay, maybe I can change it.
Go to there's a present mode.
Oh, an Xcode. Okay. Cool. Yeah, you guys are experts on that. Okay, so the first thing which I don't really like, but it's the best way of, I guess, integrating with core data, is it just throws all of the core data stuff in the app delegate, which I'm going to show you later. I mean, I think you should never really get the app delegate that dirty, because you're probably going to integrate with a lot of stuff. But you can see the three things that they include. Basically, we need to load the model. The model is the configuration file that is going to include all of the core data entities and all of the relationships and types. And once you get the NSManage object model, which you can also load through the bundle, you don't really need to specify the URL. You will need the persistent store. Where is that? Persistent store coordinator. You need to give it a URL. In this case, we're using SQLite. And you need to set the type, SQLite store type. And this one is pretty important. You can set a lot of options here about core data. If you want to sync core data with iCloud, if you want to do migrations, you can do a lot of stuff here. We're going to go a bit through the migration that it's using here, but we're really not going to see anything about iCloud. I think it's a completely different topic. But yeah. And just as easy as that, the persistent store coordinator is going to load the manage object context here. And it's basically just that. You just set the persistent store coordinator, and this is the guide that you're mainly going to use for everything. This is the guide you're going to use for inserting on the database, saving. You need to save the context every time you change it. That's really important. Deleting objects, editing objects, all of that. You need to do it through the context. So this is a guy who's going to be touched by pretty much everyone, and you really don't want to have it on the app delegate because you're going to be importing the app delegate pretty much everywhere. And yeah, this basically is just that. Core data stack. Let's see what yeah, basically just that. So let's go through the data model, which is pretty standard. I mean, it's all UI. I guess you can edit it manually. You can just do it through Xcode. You have here add entities. You have properties here. You can select different types. You can set relationships between objects. We're going to see a bit of that. And let's run this thing. I haven't changed anything. You can just go yourself, go in Xcode, create a new project, select core data, and you be able to see all of the basic boilerplate code. Well, we basically have only one entity with the timestamp, and that's all it does. That's a basic Xcode project. We can go a bit through the master view controller. As I told you, you basically definitely need to get the manage object context, that you're going to use it everywhere. You're going to have something called entity descriptions. That are the description of every entity that you define in the configuration file. You use that for inserting new objects on the context. And pretty much just, this is pretty straightforward. You can set the values, and then at the end every time you need to save the context. Otherwise, it's like nothing happened. If the app crashes, nothing is going to be safe. And the other thing that is pretty important here is that usually it's a common mistake, is that you guys probably going to use some of the data on a table, and then usually some people there load all of the data at the same time, and then they just reload the table. Well, for that we have the fetch result controller, which is pretty awesome, I'll say. It basically handles all of that. It handles section on the table, lazy loading for each section, and it's really, really fast. Like you should never use, unless it's pretty small data, loading all of them at the same time. You can just use the NSFetch result controller, which basically, let me see where they create that. It receives like a query. Yeah, here. So this is how you create a fetch result controller. You need to create a fetch request, which is the entity that we're pretty much going to use everywhere in core data for fetching stuff. It describes the query. It's pretty much the SQL query, but it's an abstract way of not handling with the storage. You can just change storage pretty easy, and it will still work. So in this case, we're saying that we're going to use an event as an entity description. We're going to create it on our current context. We set the entity on the fetch request. And this is pretty important. We set a fetch batch size. And this is for the table because we're going to be loading items in chunks of 20 items. And you can tweak this a bit depending on your data, and you can have you can profile that to see what is the optimal size. And then we're going to have a sort descriptor that is going to help us describe the timestamp, and we attach that to the request. And then we're just going to create a fetch result controller with that. And I'll show you in the cell row for index path. Where is that? Here. Configure cell. Here. Basically, it's just like a table. You just call object at index path with the index path, and he's going to do all of the magic for you. He's going to load it lazily, and you can scroll pretty fast without having to load all of the objects at the same time. All of this is just the standard core data. So we're going to go a bit more into details now, but first I want to show you a different thing. So, and I think this one is pretty interesting. In my mind, this is the usual way I handle core data with my custom pattern. So I still have the same things. I have the storage, I have the persistent store coordinator. In this case, I have one or more contexts because I need the context per thread. So you're definitely going to have one for the main thread. And then I handle all of those guys in a singleton that I can use handily all over the app. And then instead of having all of the entities inherit from the NSManage object, I'm going to have a default entity that I can use for a code that is shared between entities. I think that's pretty handily. And then I'm going to have data access objects. Default data access objects that is pretty much going to have a lot of the boilerplate queries because you usually repeat a lot of code and core data. If you're listing entities, is pretty much the same way. The only thing that changes is the entity description. And yeah, I'm happy to discuss this after the talk. It's like usually the way I implement core data. I think it scales pretty cool if you know how to handle this part of having different contexts per thread. The context, you can actually build a tree of contexts. So you can have a father context with different childs and different access to objects. The only thing that you never should do is pass objects between contexts. You should never do that. Like you list your entities in a background thread and then you pass it to the main thread and just use it normally. You should never use that. And yeah, so I did like a quick sample this weekend with just this standard pattern and core data, and we're gonna watch that. Who's excited? Yay! Yeah, not this one. Example 2. Cool. So let's go through the pattern that I just showed you. So this is my singleton. I call it store manager, and it handles the persistent store coordinator, it handles the model, it handles the context that is actually the only one that shares on the interface. Probably the only one that your classes should be using. It has a method for getting the instance, saving the context, and that's pretty much it. And then on the inside, it builds the context. Well, this is pretty much what we have seen, only that I have it in a singleton. It loads a persistent store here. I'm still using SQLite file. I said I'm using SQLite file. I have some of the options here that we're going to see later that we can set here on the persistent store. And yeah, that's pretty much it. We have to load the model, of course, from the configuration file, and a method for saving the context, which I usually check if it has changes or not. It usually looks really different. Maybe I'm getting too much into multi-threading, but this one looks really different one if you're multi-threading stuff, because usually you need to save your background context, merge it with the main context, and that's a bit tricky. And yeah, that's all the boilerplate. The model, I just created a pretty standard model. You have a football team, it has a country and a name. The football team has all of the players and through a relationship. And then the player has a name, skill, and then it has a team. Let's run this so you can guys see it. Cool. So here I can just create random teams. Let's create a couple, then I can just create players, random players. Yay. And then here I can watch players per team. And I also have a weird query here where it tells me how many other countries have how many other teams have players from this country, in this case Italy. Yeah, so it's just multiple relationship between teams and players, and that's pretty much it. So let's go through it. The first thing, which is pretty handy, is that every time you define all of the entities here, you define the properties, and then you can just go create new file. You go to core data, create the new manage object subclass, select the model, which you can have multiple ones, and then just select the entities, and it's going to create them all for you. So I have my entities here. They're all inheriting from my default entity, which in this case doesn't have much, but just part of the pattern I show you guys. It inherits from the NSManage object. That is really the one using the core data. And then once you export the files of the entities, you can select either if you want to use just NS object types like number, stuff like that, or you can just use row types, ints, and stuff like that. You can decide that. And then I have my relationship here. A player is going to have a football team, and then on the football team, and this is generated by core data, I have my players, and I have my generated methods for adding players, removing players, and all of that stuff. And let's go a bit through the data access objects. So I have my default one, who is the father of all of those. I have a method called list entities, one for building the data access object, one for saving, which in this case it saves the context through the singleton. Yeah, it pretty much just save it through the singleton. And then I have one for list entities. I choose this one because it's mostly, well, one of the most common queries. Basically, there's no query, just give me all of the objects. And you're probably going to need it for each entity. And then I have my player data access object and the football team. The football team has a couple of interesting queries. So first, it just has a list entities with the football team. That's going to be handled by the father. It has one method for creating a new team, just a randomly one. I get the context here through my singleton. I insert the new object on that context with the football team class. Set a bit random of the values, and then I just say that. Okay. And then I have another method for just give me a random team on the database. Just give me a random team. This is, you always have to do this boilerplate stuff. Like you need to define an entity descriptor that you're going to use on your fetch request. First, I call one query. This is for just counting all of the objects there, and then I can set a fetch offset from a random of all of the total count, and then just give me one. Which this one is pretty important because in most of the queries, especially if you're handling a lot of data, you don't want the context just giving you all. That will be really insane depending on your data. And core data can be really slow sometimes if you really don't optimize the queries. yeah, and then at the end I just execute the request, and that's pretty much it. And then I have another query, which is the one I use here for knowing which teams have players from that country also. I still use the football team, and I check that the country is the same as the one I'm giving on the parameters. And then I do a cool thing here. That is, I'm accessing the relationship on each entity, and I'm saying count all of those objects and tell me if they're more than 0, because I don't want a team that doesn't have any players be included. And yeah, and then I just execute the fetch request. And you can see you really don't know, you don't need to know any SQL. You really don't know which type of data storage you're using. You can change that pretty easy if you're using different storage for, like, let's say unit testing or chipping. And yeah, and this is one way of creating a predicate, but you can do it through functions that you just give it a block, and then inside you do the query, like you check literally if the country is equal to this string and things like that. Usually contains that they're really bad in queries. If you could use a start with, it will be, or begins with, it will be much better in terms of performance. But that's I think that's one of the cool things of core data, that you're going to start to play a lot around this profile, how the queries are doing. You can all do that through Xcode. And at first it's, I don't know, pretty simple, a lot of boilerplate, but it gets a bit tricky if you want to scale it. And yeah, let's look at some of the things. On the app delegate, basically I just create a singleton for the first time. He's going to handle all of the context and persistent store. And then on the controllers, which I do a couple of bad stuff, like listing all of the entities at the same time. I know there's a couple of entities, but maybe you should never use this. It really could go really wrong. You will see it on the main thread goes really, it just stops. And yeah, just list all the entities and create. I have a button for creating a new team, and then list them again. And yeah, and then I just show the football team. This is pretty much it. I have a second view controller for the players, the other tab, and it basically just does the same thing. You get you list all of the entities. The data access object already know how to handle that. So on the controller layer, you really never access the context. You access the data access objects, and they really know how to handle all the data and all of the entities. And yeah, I don't know if you guys have any questions on this example. The football teams, players, one relationship, couple of queries, nothing to worry. Okay, so let's continue with the presentation. Let's look at some of the things we've seen. The first thing, maybe let's go back to the project. This is probably the first thing. So you run your project, you've created your model, looks kind of good, looks like it's running, and I forgot to include something. We're editing the model, we really don't know what type of entities we're going to use. I go to the player, I want to add something like, I don't know, like speed. You can see you have different types. That's all I'm doing. It's just adding one parameter to the data storage. I'm just going to run it. Boom, crashes immediately. And this is the first thing pretty much everyone is going to see on core data, which is really stupid, I'll say. If you start changing the configuration file, it just crashes, just like, fuck you, no. And which is also a bit scary if you're like handling a big team and we're going to ship to the Apple Store and suddenly someone changed something, and it's like it can crash for everyone, just like immediately. You didn't even see nothing. But the cool thing is that you can fix it pretty easily. So core data has a thing called automatic lightweight migration, which it basically does some check if we need to do a migration of the storage configuration, and it just does it on runtime. So the only thing we need to do is that we need to set some flags, as I showed you on the options when you're creating the persistent store. And you need to add the model version, which it basically is you're gonna have different versions depending on the things you're changing, and then it's gonna migrate to the next one. And you just set the latest version as default. That's pretty much it. So let's see some of the things we've done. So now we know it's crashing completely. It doesn't open at all. I can just go to the options. Where is that? Okay. And I have 3 flags here. I can talk about this one later, but basically for migration, you need these 2. You need the ns migrate persistent stores automatically option. You know, Apple loves using huge names. This is probably a small one. And the ns infer mapping model automatically option. You can find this on lightweight migration on the Apple docs on core data. Is basically just says that, just include those flags. And then we're going to set that on the options. So that's the first thing. The second thing is that we need to tell this guy to have model versions. So we go to editor, add model version, just add the second one, and here we're going to set the current one as number 2. We can put it this. I usually put it this. On this one, we're going to remove the speed because we don't want the current one crashing. And then on the second one, we're going to add speed. And then I can just run it. And yay, this time it works. So, I mean, I'll say some of my friends, they usually get scared the first time. It's like, just crashes, what's going on? And you need to do some Googling or something. But you can see it's pretty easy, and core data includes a lot of features like that. You really need to go through the documentation and just be amazed with that. And so let's continue with the presentation. So let's go a bit through some of the common mistakes that I've just like on the top of my mind I've done, or people around me have done. Not adding the automatic migration. We just tested that. I'll say that's number 1. You just change the model and it doesn't work. The same with model versioning and migration. Don't use it too much, because if you have a lot of people, you're gonna have like a lot of versions. It really doesn't scale that well. So I'll say the first time you're gonna use core data, plan really your model and all of the relationships and entities, so it doesn't become a problem in the future. Loading big amounts of data in the main thread. I'll say most of the times you will get through one of these cases, and I mean you could try to optimize the queries, do a lot of stuff, but the best thing is just load the data on a different thread, and well, it's gonna get a bit tricky, as I said. Listing all the entities instead of using an NSFetch result controller, I think is just a must. Apple is already doing all of the persistence there. It's completely built, so you can use it with the UI table view, and it just works. And the next thing is that passing NS managed objects between threads. I think this is the first thing you're probably gonna do. You're gonna try to load your data on a background thread and then let the UI load, and it's like, yeah, here's the data. No, you can't do that. You could give the other thread something that core data calls object IDs, which core data is not really relational, but it still has a specific ID for each entity. That it could change depending on the object is temporal and if you haven't saved the context, so it's still you shouldn't trust it that much, but you could do that. Objects, never. Using multiple contexts, I really want you to be inspired with this and really get into multi-threading with core data, because I think it's just an amazing topic. I mean, we can argue on this, but I really never like to get the app delegate that messy, because I just think that's just bad development, and you could do that with core data pretty easily. I mean, on the Apple example, is just there. The next thing that I mean, it's just, I don't know. People they forget to save the context. I think it's like the first thing. If you're inserting or editing or doing any type of stuff, you could save the context on different times. You could save it maybe when the user is closing the view or stuff like that. But you definitely need to save it if the user is going on the background or if the app is finishing, because otherwise none of the data are going to be passed from the context to the persistent store. And then having heavy objects with big blobs. Well, the thing is that when you do a query to core data, it just loads like a description. It doesn't load any of the data. It's just, if the first time you access one of the properties, it's gonna load the whole object. So if you're planning to like listing all of your objects with images and then just like accessing all of them, well, it's gonna load all of the images on the memory, and that can get really tricky. Especially if you're not using the images at all, like you're just using a couple of properties. So I usually recommend just having either URLs on the file, or you can just tell core data to just give me some properties of the entity when I'm asking for the query. You could do a couple of things here. Just don't include the images on the entity or music or anything. It's a big blob. And then some of the random tips. Maybe I missed something. I just did it a bit randomly. So the first time that you create a fetch request, or every time, you need to include a predicate. And this is something really expensive to do, because you're giving it a description where you say like, yeah, give me all the items that are contain this string or are in this limit or whatever. And it needs to parse it, and it needs to parse it different depending on the storage type. But what you can do is that you can create the preload or pre-create the predicates, I don't know, once you start the app or whatever, especially if it's queries that you are executing a couple of times per minute. You can just do predicate with substitution variables. So you create a predicate with a couple of variables, and then you can just replace it with your values every time we're gonna execute the query. The second thing that is the same thing that the fetch result controller uses is the fetch limit and the fetch batch size. You could do it manually if you're loading a table or not, but if really you don't need to do that much, execute that much data at the same time, always use a fetch limit, so you can know that you're only going to have a couple of objects in memory. The third thing, which we use a lot, I think is pretty handy. You can just say, instead of giving me the whole object, just give me a dictionary with some of the properties that I'm going to tell you. And you can just give it a dictionary with, I don't know, just give me the football name, and that's all I want. I don't want the relationship or anything. And it's going to give you an array of dictionaries with all of the data. And the next thing, which, I mean, you could use it or not, and most of the times you will try to use core data as relational, especially if you're using an SQL file. So always include unique IDs, and you can handle that yourself instead of trusting core data or not. Make them indexable if you're running queries through that. And yeah. The next thing, which I think is some of the basis for getting into core data with multi-threading, is init with concurrency type. You can use that when creating the context. So you can have different types: the confitment, the private queue, the man queue. I'm not really going to go through them, but basically you can use the context through different things on different states. If it's on the main queue, or if you're using a different thread, or every time you save the context, you want to save it on a asynchronous. You can do a lot of stuff, and this is basically the basics for getting multi-threading. And the next thing with that is that you can save, if you're having a private queue concurrency type, you can save the context every time asynchronous. So usually if you're doing a lot of changes on the context and then you just save it at the same time, it takes a while, especially if there's a couple of hundred items there. The next thing, which I think I already mentioned, is use to start with instead of contains. In most of the cases, this being proved by Apple is the most effective string query if you're really doing the string queries. And then the next thing, which maybe you will need it, is that sometimes you just want to create temporal objects. I mean, you want them to be on the context, but you will never want them to be safe on the data, because maybe the user is just creating an object, and if they click cancel, you don't want the object to be safe and things like that. You can use that when you're inserting a new context. You can just pass a null instead of the context, and it will work perfectly, but it will never be safe. And then the last thing, which you can do, and you can get really into a lot of that stuff, is that core data handles object wraps in lifestyle, so you can do like rollback pretty easily, but it takes a lot of time. It takes a lot of part of the performance. So if you just set the window manager as nil, it will save you a lot if you're not really using that. Like if you really want to edit objects in different states and you want to roll back pretty easily, you can do that through core data, but it's I don't know. I think it's not really worth it. And yeah, where to go next? Multi-threading with core data. I really insist on this one because I just love it. And I forgot to add here, but iCloud with core data is pretty interesting. You can basically just sync your database with iCloud seamlessly through several devices, and it just works. And then the last thing is that a bit of a shame, as always. Yes, we're hiring. So if anyone is interested of what Livestone is doing and how can we improve the lives of a lot of people in the world, talk to me. Yeah, that was it. Cool. Any questions, maybe?
Yeah. Core data and iCloud, does it really work?
Yeah, but it's good when it works. When it doesn't work, you have no idea.
No.
And it gets a bit tricky, like especially if you're handling big objects. It's like suddenly you have it on your iPhone, and then on the iPad it's not there, it's still syncing and stuff like that. So you probably need to add some UI stuff where you're syncing or things like that. It doesn't work that seamlessly, depending on your.
Have you tried any source libraries that help dealing with?
Well, you can use the AF networking version. I don't remember the name of the repository, but there's one for syncing core data with the backends and stuff like that.
You mean AF incremental storage?
Yeah, that one.
Okay.
You can use that one. Yeah. Any other questions? Yeah.
Do you have any experience with the fetch results controller and the UI collection view? Is it
Haven't used it directly with the UI collection. I've used it with tables, but what's the problem?
Begin editing, begin and end doesn't. They don't exist on the collection view. That's I've run into some problems with that one.
Ash Farrow has a
yeah, there are a couple.
I mean, it's handling for developers, but you can always go hands-on and do the fetch batch size yourself and get the items per section. I guess it works pretty well.
Else you can just wrap it around you can save all the changes in dictionaries and
that's what the blog posts are all about.
Oh, okay.
Yeah.
I kind of solved it my own way, but yeah, it's not as easy as with a UI table view.
Yeah.
That's my.
Definitely not. Any more questions? So what do you think about core data? Will you use it for your own app? Or you will still go hands-on with the database? You could do it. Cool. Thank you, guys.
Great.